In this episode, we're going to treat Git as what it really is for a Linux administrator, a safety system for your changes, not a fancy developer hobby. When you manage scripts, configuration templates, documentation, and small tools, you are constantly changing text files, and those changes can be hard to track once time passes. Git gives you a timeline of what changed, when it changed, and why it changed, and that becomes incredibly valuable the first time you need to roll back a mistake or explain a change to someone else. Beginners sometimes think Git is only for large software projects, but the daily workflow is actually designed for small, repeated changes that you want to keep organized. The goal here is not to memorize commands, but to understand the flow. You create or copy a repository, you make edits, you review what changed, you record a commit with a message, and you use history to learn and recover when needed. Once you see Git as a routine habit, it becomes a calm, predictable part of your daily work. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A good mental model is to think of a Git repository as a folder that has memory. The files you see are the working area, which is where you actually edit text, but Git also keeps a hidden database of snapshots that represent your project over time. Those snapshots are not random backups. They are organized into commits that form a history, and each commit has a message that explains the intent. That means Git is not just preserving the final state of your files, it is preserving the story of your decisions. This is especially helpful in admin work where the same script might be changed to address a new requirement, then changed again to fix a bug, and then changed again to support a new environment. Without version control, you might end up with file names like script-finalfinal2, which is a sign that you have no reliable history. With Git, you keep one clean project, and the history carries the timeline for you. There are two main ways you usually begin working with a repository, and understanding the difference helps you avoid confusion later. If you are starting a brand new project, you initialize a repository in an existing directory, so Git begins tracking that folder's files. If you are working on something that already exists somewhere else, like a shared repository, you clone it, which creates a local copy that includes all its history. The key point is that initialization creates an empty history that you will build, while cloning brings down a history that already exists. For a beginner, the important habit is to think of cloning as joining an ongoing story rather than starting one. When you clone, you are not just grabbing files, you are also grabbing the record of prior decisions. That history can tell you why something was done a certain way, which can prevent you from undoing an important fix accidentally. Once you have a repository, the daily rhythm is all about small changes. You edit one or more files, and then you check what changed before you record it. This review step is where many beginners either skip too fast or get overwhelmed, but it is one of Git's best features because it turns your work into a deliberate process. The tool for reviewing changes is diff, which shows you the difference between what is saved in the repository history and what is currently in your working files. You can think of diff as a spotlight that reveals exactly what you changed, line by line, so you can catch mistakes early. In admin work, this is huge because tiny typos can cause large problems, and it is far better to see them in a diff than to discover them during a service failure. Over time, you start to trust diff as a pre-flight checklist. You look, you confirm, and then you proceed. After you review changes, Git asks you to be explicit about what you intend to record, and that is where add comes in. Beginners often misunderstand add as uploading or saving, but it is really about staging, which means selecting changes that should be included in the next commit. Staging lets you separate work that is ready from work that is still in progress, even if both are present in the same working directory. For example, you might have made a change to a configuration template that is ready, and also started an experimental change in a script that you do not want to record yet. Staging lets you commit only the ready change, leaving the experiment for later. This ability to commit small, focused changes is one of the reasons Git history stays useful. When commits are clear and single-purpose, it is much easier to understand what happened and why, and it is much easier to revert a specific change without losing other work. A commit is the moment you turn staged changes into a permanent, named snapshot in history. The commit message matters more than beginners expect because it becomes the explanation future you will rely on. A vague message like updated stuff might feel fine in the moment, but it becomes useless when you are searching history during an incident. A good message describes intent, not just the mechanical change, because intent is what helps you reason about whether the commit is related to a problem. For admin work, messages like handle empty input, tighten config parsing, or update defaults for new environment tell you the story quickly. Commits are also how you build trust with teammates, because a clear commit message is a kind of professional courtesy. It says, I made this change for this reason, and you can follow along without guessing. Over time, your repository becomes a tool that explains itself rather than a pile of changes that only one person understands. To navigate that history, you use log, which shows you the sequence of commits, usually from newest to oldest. Think of log as your project's timeline, where each entry is a decision point. When something breaks, log is one of the first places you look because it answers the basic question, what changed recently? Even when nothing is broken, log helps you learn your own patterns, such as how frequently you commit, how large your commits are, and whether your messages are meaningful. Beginners sometimes treat log as something only used in emergencies, but in a healthy daily workflow it is used casually, like checking your notes. Seeing history regularly makes Git feel normal, and it helps you build the intuition that small commits are easier to manage than giant ones. It also helps you connect changes to outcomes, which is a powerful learning loop for any administrator. Another key part of daily work is understanding how to compare not just your working changes, but also different points in history. Diff is not only for current edits, it is also for asking questions about what changed between two commits, or why a file looks different now than it did last week. In admin terms, diff becomes an investigative tool. If a script worked last month and now it fails, you can use diff to see exactly what changed, rather than relying on memory. This makes troubleshooting far more precise and much less emotional, because you are looking at facts rather than hunches. It also encourages good habits like making one change at a time and committing it, because then the diff between commits is small and the culprit is easier to spot. In that sense, diff is not just a display, it is a discipline. It rewards focus and punishes chaos. Config is another piece that looks small but affects everything, because Git needs to know who you are when you commit and how you prefer Git to behave. The identity part matters because commits record author information, which helps you trace decisions, especially in shared repositories. Your configuration can also include practical preferences, like what editor opens when you write a commit message, how diffs are displayed, and whether certain helpful behaviors are enabled. For beginners, the important idea is that Git is not one fixed experience. It can be adjusted to match your workflow, and those adjustments can reduce friction. When Git feels annoying, people avoid committing until the last minute, which creates large, messy commits. When Git is configured to be comfortable, committing becomes a natural part of finishing a small unit of work. That comfort is not a luxury. It is what makes the healthy workflow sustainable. Now let's talk about gitignore, because it is one of the first places beginners accidentally pollute a repository. A repository should track the files that represent your project, not the clutter your tools generate while you work. Many projects produce temporary files, caches, compiled artifacts, logs, or local settings, and those files can change constantly. If you commit them, you create noise in the history and make it harder to spot meaningful changes. A gitignore file is a set of rules that tells Git which files it should not track, which keeps your repository clean and focused. For admin work, this matters because you might generate output files, local notes, or environment-specific artifacts that should never be shared. A clean ignore policy reduces the chance you accidentally commit sensitive data, temporary logs, or machine-specific information that does not belong in version control. The daily Git workflow becomes powerful when you combine these pieces into a simple, repeatable loop. You make a small change, you review it with diff, you stage it deliberately, you commit it with a meaningful message, and you occasionally look at log to keep a sense of history. This loop creates a feeling of control because you always know what state your work is in and what will happen if you need to go backward. It also changes your behavior in a good way. You start to break work into smaller chunks, and you start to treat each chunk as a decision worth recording. For beginners, the biggest psychological shift is realizing that committing is not a final, scary act. It is a normal checkpoint, and you can create as many checkpoints as you want. That makes experimentation safer because you can try something, commit it if it works, or revert if it does not, without losing your place. To close, remember that Git is best understood as a lightweight control system for change, and the daily workflow is simply the way you keep that control without adding stress. Initialization and cloning are how you start tracking a project. Adding and committing are how you record intentional checkpoints. Diff is how you verify what changed before you lock it in. Log is how you explore history when you need answers. Configuration is how you make Git comfortable enough to use consistently. And gitignore is how you keep the repository clean and safe. When you practice this rhythm, you stop fearing mistakes because you have a reliable way to see them, explain them, and undo them. That confidence is exactly what you want in Linux administration, because change is constant, and the ability to manage it calmly is one of the most valuable skills you can build.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.